structural diagram is just literally a figure showing the carbon chain with the hydrogens attached to it in the hydrocarbon, and the length of that chain, well, it depends. You'll derive that from the name that you'll be given, or the chemical formula, or maybe you'll be given a structural formula. The chemical formula is a simple count of atoms, so you've got your carbons and your hydrogens there. Your structural formula reflects the structural diagram. Effectively, it can be thought of as just being removing the lines that show the bonds, and you're writing it in a text form. So you've got that C at the front. The first carbon has 3 hydrogens attached. The second, third, fourth carbons have 2 hydrogens attached, and the 5th carbon has 3 hydrogens attached. And then the one you'll mainly work with is the condensed structural formula. This gets really long really fast, and if there's a lot of CH2s, why not just bunch them together in a single bracket and tell me the number of CH2s that's present. So you get a CH3, CH2, 3 of them, and then CH3. And the ball and stick model is just a pictographic representation of all of the above. Now, this particular diagram, which I got you to copy, a lot of information there, and what primarily we're interested in are these 3 classes, the alkanes, the alkenes, and the alkynes. And what distinguishes them from each other, so you've got this name difference. An alkane only has single bonds present. So that carbon chain only has single bonds. In an alkene, there's at least 1 double bond, and for year 10 level, we're usually pretty gentle, and we only give you 1 double bond. Okay? So there'll be a double carbon bond somewhere. So if you want to put on your diagram a little double carbon bond, you can do that. And these are unsaturated. When we say the word saturated for an alkane means it has the maximum number of hydrogens possible hanging off that carbon chain, because every carbon only has a single bond. Whereas alkenes and alkynes are unsaturated because of the presence of a double bond here or a triple bond for the alkyne. Now, how do you know the number of hydrogens to number of carbons present? They will follow these formulas where the N in each case is the number. So if you have 6 carbons here, you'll have 2 6s as 12 minus 2, so you'll only have 10 hydrogens there for whatever alkyne that is. So they will all conform to those formulas, and you will need to know those formulas. But they do follow a pattern. H2N plus 2, H2N, and then H2N minus 2. Okay? Now, we'll also talk a little bit about these naming conventions. We'll do that later on. But in essence, for the enes and the ynes, where is the double bond or the triple bond located? We use a number to designate which carbon, and that number can be read from the right or the left. It's bidirectional. And so for but1-ene, it's the first carbon, it's an ene that has the double bond. For but2-ene, it's the second carbon that has the double bond. I know it's a double bond because it's an ene ending. The enes have the double bonds, the ynes have the triple bonds. Okay, now this particular activity, this is what you're going to draw up in your book, but we'll work through a couple of examples. So I mentioned before you need to know the prefixes. Meth is 1, eth is 2, 3 is prop, 4 is but, 5, 6, 7, 8, 9, 10. Okay? Don't draw it now. Just let's work through a couple of examples. Now, we've got our alkanes in the formula. Alkenes, remember, have that double bond somewhere. The alkynes somewhere have a triple bond. Now, let's have a look at this. Meth, meaning 1 carbon, ane, methane, has 1 carbon, 4 hydrogens around it. Now, why don't we have, is there such a thing as methene? Why? Why is there no methane or methane? Yeah?
Is it because hydrogen only shares 1, it can't share 2?
No.
So, oh, damn.
Oh, but I know what you're thinking. I know, you're kind of right. But these names are for double bonds between carbons. do we have? 1. How can you have a double bond between, if you only have one carbon? Yeah? And you were thinking a double bond between the carbon and the hydrogen, were you?
Yeah.
Yeah. That's also true.
Okay.
Yeah. And you can't have a triple bond between 2 carbons when you only have 1 carbon. So let's go to the next row. Okay. Now, for this table, you're not drawing these diagrams. You're going to do that on your worksheet, on that workbook that I gave you. And that'll be the first thing you do because they're pretty straightforward. But you're going to be doing the names and the actual condensed structural formula will be best. Now for this, the condensed structural formula and the structural formula are the same thing because there's no multiple CH2s. So here we have ethane. Ethane has only single bonds because it's an ane, 2 carbons on the chain, and then around that 6 hydrogens. Does that obey our rule, CN2N plus 2? Well, 2 carbons means 2 times 2 is 4 plus 2 is 6 hydrogens. And we have 6 hydrogens. So that's ethane. And the condensed structural formula is that carbon has 3, CH3. That carbon has 3, CH3. Yep.
Does the N represent the number of carbons?
The N represents the number of carbons. So it could be 1, 2, 3, 4, up all the way up to 60. If you had 60 carbons, you'd have 122 hydrogens. It's 2 times 60 plus 2, 122.
Do you simplify that formula so it's like CH3 in brackets 2, like for ethane?
No, you cannot do that.
Why?
We don't as a convention. We just leave the CH3s alone because they're sort of like bookends. And then we have all these CH2s usually between them. Yeah. So we'll use the same thing all the way through because you were thinking maybe for this one but none of the others. But no, we'll just leave them alone. Now ethene, again, eth meaning 2 carbons, ene meaning a double bond somewhere. Not rocket science. There must be a double bond between those 2 carbons. And how many bonds can each carbon form? What's the magic number?
4.
4. It's 4, it's 4, it's 4. That carbon has 1, 2, 3, 4. That carbon has 1, 2, 3, 4. And the condensed structural formula is CH2, CH2. And pay attention, you have to show the double bond where it is. So, when you draw these, do you want to save yourself a lot of time?
Yes.
Put the double bond in the position 1. Don't put it in the middle. It'll make it really difficult. So for all of these, put the carbon, the double bond or the triple bond at the first location. So for this one here, you'll have your 3 carbons, put the double bond there. Okay? It'll make your life a lot easier. Now, and then ethine, there's the ine, eth meaning 2 carbons again. There's 2 carbons, triple bond between them, and of course, you can only have a single hydrogen because each carbon has only 4 bonds. So 3 between those 2 carbons, 4 bonds, and the triple bond also shown in our condensed structural formula. Now, we're not going to do these naming conventions that we've spoken about. We'll do that a little bit further down, but you should be aware of them. So what we're going to do is, well, let's do the third one. So, propane. Prop means 3 carbons. Okay. It only has single bonds, and we then fill in our hydrogens around it, and then we read that off. Carbon with 3 hydrogens is CH3. Carbon with 2 hydrogens, CH2. Carbon with 3 hydrogens, CH3. Okay? And that's, the name of that is propane. This one here is propene, and it has 3 carbons, but there's a double bond. That can only have 2 coming off it. That can only have 1 coming off it. That can have 3 coming off it. So it has CH2, 1 CH hanging off that, CH3. Where's the double bond? There. Okay. Finally, propine. Again, start with the carbon spine. At position 1, put the triple bond. that can only have a hydrogen off it. Now that can't have anything coming off it, because there's 3 there and 1 there. That can have 3 hydrogens coming off it. And you get a chemical formula CH, triple bond, C, CH3 would be the condensed structural formula for propyne. And it goes on from there. So, as I said, you're doing these diagrams, these structural diagrams, not in the table. You could do, but I've given you a work booklet, and so you can do them there. I'd recommend doing those first. So it's the second page and second and third page. Do those first. It'll make it simpler, because then you can just read off the structural formulas, and the names you can derive from the table itself. Okay? I'd recommend doing the table in pencil. So if you want to make changes, it will be easier to do so. I'll come around and help